implement centralized DHCP server with MikroTik. So in this video, implement centralized DHCP server with MikroTik. We will have multiple MikroTik routers in our demonstration. These routers will have their respective local area networks to be on different subnet. These routers will accept DHCP discovery, but it will be relayed to the central DHCP server. In this tutorial, you will learn how to configure a DHCP server and a DHCP relay in MikroTik. So perhaps you can find some usage of this in your current network to have some sort of central management of your IP pools, perform reservation, and other DHCP tasks only in a single router instead of managing multiple devices. We will verify our configuration by having some test clients and see if these computers have obtained an IP address in the correct subnet from our main DHCP server. So for this video tutorial, we will be working with this topology. So we have a CHR, cloud hosted router, which is empty-main that is connected to the internet, and Ether2 is connected to the switch, and the switch is connected to our 3 site routers. So our empty-main MikroTik router will be the sole or will be the only DHCP server in this environment. So this DHCP server will serve the local area networks on the site routers MT1, MT2, and MT3. So we should have a DHCP server configuration that will serve the LAN network or the local area network 10.50.50.0/24 on the site 1, so under the MT1 router. So we should also have another DHCP server, or the server will also cater to the networks that are connected to 172.16.0.0/24 or under the MT2 site router. And finally, it should also lease IP addresses in the network 192.168.1.0/24 under the MT3 site router. So you might notice that we have the private or the example of private networks here. So we have the 10 subnet, which is a class A IPv4 for private network. We have also the 172.16.0.0 private network, and we have also the 192.168 private network. So for our examples, so we have covered ground, or we have covered the examples of private or valid private IP networks. So here we have MT1, MT2, MT3 site routers. So they will be configured with the DHCP relay configuration. So meaning to say MT1, MT2, and MT3 are not really DHCP servers. So we don't have any DHCP server configuration here. However, they are a DHCP relay, which is just a proxy that is able to receive the DHCP discovery and requests from the computers or clients that are connected on their respective LAN, and they will relay. So by the term DHCP relay, they will relay to the configured DHCP server, and hoping that the DHCP server will then offer or provide the respective IPv4 network that is on their site. So later, for our verification and testing, PC1 should be able to get 10.50.50 that something. So it should not get 172 or 192. And after it acquires or obtain an IP address, we should test that it can go through the internet. and also likewise to the PC2 and PC3, they should get or obtain their respective LAN subnet. Okay, so I have powered up the mt-main, which will be our DHCP server in this video tutorial. So we have also MT1, MT2, and MT3, which acts as the DHCP relay and as our site routers, from which our test clients are directly connected. So they are all CHR or cloud hosted routers. So we will first configure the mt-main and go ahead and configure the settings for our DHCP server role. Okay, so we are now inside the mt-main configuration. So just a quick recap on where we are. We are here at mt-main. It's Ether1, it's connected to the internet, and Ether2 is connected to the switch. So the Ether2 is to be configured with an IP address of 10.00.254/24. So those will be the local area network. So between our mt-main and our site routers. So let's check first. So IP DHCP client. So Ether1 is connected to the internet router and it acquires an IP address. So also it comes with the default route, and we have also configured our DNS server, and we have also configured our network address translation masquerade rule. So for a quick check, let's do a ping. For example, let's have a quad 9s and there is a reply. Let's have a quad 1s and there is a reply. Next, we will configure the IP address of our Ether2 that is going to the switch. So we go to IP addresses. So we have this IP address for our Ether1. This is our internet connection. So we click the plus sign and we put in the required IP address 10.00.254 on our Ether2. Let's put a comment. So to our site routers. So to give us some documentation or at least description for what is the purpose of this interface. Next, we are now ready to configure our DHCP server. So you can close this IP address window. So but first we will configure the IP pool or the ranges or the range of IP addresses that we are about to lease to our clients. And we should refer to the network or the local area network that is required. So we should create a pool for 10.50.50. We should also create a pool for 172.16.00. And finally, we should also create a pool for 192.168.1.0. In order to do that, we go to IP pool. And as you can see, we don't have any configured pool yet. So we will click the plus sign and we will configure 3 IP pool. One for class A, which is the 10.50.50 network, and one for class B, and the other or the last one will be for class C. So I should perhaps name my pool for example purposes only class A pool to refer to that site number 1 LAN. Okay, so perhaps we will standardize the addresses that we will be giving out. So let's say we'll start with 10.50.50.100 to 10.50.50.200, and this will be the same or true to the rest of the classes. So let's do a comment. So this one is for site number 1 pool. Okay, so we could go ahead and click the plus sign, but we could also copy. Okay, so I suggest we make use of the copy command or copy feature in MikroTik. So this will be 172.16.0 dot, so let's say 100. So 172.16.0.200. So let's change the comment, so we don't want to forget the comment. So apply, okay. So we now have two IP pools, so all it's left is the class B pool. So we go and copy again, so class C pool, and that will be 192.168.1.100 to 192.168.1.200. So comment will be site number 3. Okay, apply, okay. So let's review and check whether we get it right. So we have 10, 50, 50, 50. We have 172.16.0.0 and we have 192.168.1.0, and that should be all right. So 10, 50, 50. We have 172.16.0 and 192.168.1.0 or network. Now that we have an IP pool or IP pools, so we can now continue and configure our DHCP server. So we could close this IP pool and we go to IP DHCP server menu or window, and we can click the plus sign, or we could click the DHCP setup wizard. We already have a video or YouTube video tutorial on configuring DHCP server. So we've used the DHCP setup wizard. So please check on that video. So this time in our tutorial, we will configure manually or add manually our DHCP server. So let's add our first DHCP server for site number 1. So we could term it as site number 1 server. So the interface, so remember the interface that should be going to our DHCP relays or our site routers, and that is Ether2. So we should select the Ether2. So the relay should be the relay IP address. So it's an IP address. So it should be the local area network IP address for the site router. So since we are configuring site number 1, it should be 10.50.50.1. Okay, so 10.50.50.1. So it should not be the Ether1 IP addresses or IP address. It should be the local address. So it should be 10.50.50.1. And the address pool, so since we have configured previously the class A pool, so we should select it. We will leave the values or default values for lease time, so that is 10 minutes. So the other settings we will also leave because it's not covered with our tutorial for now. Okay, so the other menus for queues and script also we will leave. So we will only configure the name, the interface, the relay IP, and the address pool. Okay, so click apply, click OK, and we can also enable this DHCP server. Next, I will add the remaining DHCP server configuration for the site 2 and site number 3. So I could add, or I could also copy again. So let's copy this and just rename it to site number 2 server. The interface will still be the same, Ether2, but the relay IP will be different. So this time it's 172.16.0.1. Okay, so the MT2 LAN IP is 172.16.0.1. So the address pool should be the same network on that particular relay IP. So that will be class B pool. Okay, so again, we will not tinker on other settings. So click apply, click OK. and it's also enabled. And finally, we'll do or configure the last one, or our site 3 DHCP server. So I go ahead and copy again. So site 3 server interface will still be the same. The relay IP, so this time it's 192.168.1.1. Okay, so the MT3 LAN IP is 192.168.1.1, and the address pool should be class C pool. Okay, so click apply, click OK, and we now have the DHCP server configuration for the 3 sites. But since we are not doing the configuration via the DHCP setup wizard, so actually this DHCP setup wizard creates or add the DHCP server configuration, add the IP pool, and also the networks. So what's left for us is actually to configure manually the DHCP networks. Let's add the respective networks. So first will be our class A, so 10.50.50.0/24. So again, it's network. So gateway will be 10.50.50.1. So it should be the local area network IP address of the site number 1 router. So we could also have some configuration here, but for our demonstration, let's only focus on the DNS server, and that's about it. Next, we will copy, or perhaps we'll comment it first. So site number 1 network before we will copy it. So the second DHCP network will be the class B, which is 172.16.0.0/24, and the gateway will be 172.16.0.1. And for our DNS servers, let's have a different one, and the comment will be site 2 network. So finally, we will copy again for our third and final network. That will be 1.0/24. The gateway will be 168.1.1, and the DNS server, let's try a different one, quad 9s. Let's change the comment to site 3 network. Click OK, apply OK, and commit to the other DHCP networks. Okay, so these are the DHCP server configuration that we need to do on mt-main. So first we have created the pool, then we have manually added the DHCP server because we are not using the DHCP setup, and finally we have the DHCP networks. So there will be no leases yet. So this tab shows all the IP addresses that are given out by this DHCP server. So right now there is none because our site routers are not yet configured, and we will go to our site routers in a moment, one by one. So we are now in our MT1 site 1 router. So a quick recap. So MT1 is here. Its Ether1 interface is connected to the switch, and it should carry an IP of 10.00.1. Okay, so the MT1 also has an interface, which is its LAN, and it should carry 10.50.50.0. So this should be the Ether2 interface. So we will configure the IP addresses for our MT1 router. Alright, let's configure. Let's go to IP addresses. So click the plus sign. Let's do first the Ether1 IP, so 10.00.1/24 on the Ether1 interface. We will comment it, so going to our DHCP server to make it descriptive. So next is the LAN IP, so it should be 10.50.50.1/24 on the Ether2 interface. So we'll also comment will be our site 1 LAN. Okay, so click apply, click OK. So we now have the 2 IP or required IP addresses for our MT1 site router. Let's have a quick check first on our MT1 and see if our MT1 is able to reach the 10.00.254 since we have an IP address of 10.00.1. So we can do that by going to Tools Ping and typing the IP address of our DHCP server 10.00.254. Let's start. And yes, we are able to reach our MT-main router. Now, it's time to configure the IP DHCP relay or the DHCP relay configuration for this MT1 router. So again, we are doing a DHCP relay so that our test client's DHCP request will be relayed to the real DHCP server. So we can configure in our MT1, we can go to IP DHCP relay and add the corresponding configuration. So unlike the DHCP server, we have a DHCP setup wizard. So for configuring DHCP relay, we don't have any. So we will really manually click the plus sign and supply the necessary settings. So we have name, interface, DHCP server, delay threshold, and local address. So we will have the site1 relay as our name. The interface, so it should be the interface that is connected to our clients or those clients that want to obtain IP address. So in the case of MT1, it should be the Ether2. Okay, so I will select Ether2 here. The DHCP server address is of course the IP address of our DHCP server. So take note, the MT-1 has two IP address, one going to internet and one going to the switch. So obviously MT1 is able to reach this DHCP server. Finally, we will configure the local address. So in the case, that will be the IP address of our LAN, which is the Ether2 IP address. So that will be the 10.50.50.1. Okay, so we'll click enable. So do you want to commit all the changes before enabling? Yes. So it's committed. So we have now our relay configuration for this MT1 router. So let's check the status. We don't have any requests and responses because our test client is not yet on. So we should be having some values here. So this is the DHCP relay settings for our MT1. So next is we will turn on our test client to see if this configuration is valid, and our client will be able to get the correct IP address. So I've turned on the PC1 client and immediately it obtains an IP address. So actually it gets the correct IP address 10.50.50.200. So you have the DHCP server process of DORA, discover, offer, request, acknowledge. So however, I want you guys to see how the PC1 acquires an IP. So let me temporarily configure it with a different IP this time. Okay, again for just a demonstration. So I am doing a static IP and I will now proceed to configure back this PC1 to DHCP or obtain so that you will see if how it acquires. So IP DHCP, and yes, there is now the DORA, discover, offer, request, acknowledge, and yes, it acquires the correct IP address of the 10.50.50 network. So here, if we check our MT1 DHCP relay status, so we see now there are requests and indeed there are responses. So that's why we are able to get an IP address. So we could double check on our MT-main. So we go to the IP DHCP server. So under the leases tab, and as you can see, there is now a lease to that PC1 test client, and the correct IP address is also reflected to the client 10.50.50.200. So let's check whether on our PC number 1 we are able to go to the internet or reach the internet sites or IP addresses. So PC1 got an IP of 10.50.50.200. It has a gateway of 10.50.50.1. It acquires a DNS server IP of quad 1s. So you see that the DHCP server is listed here 10.00.254 to prove that this IP address was obtained on this DHCP server, which is our empty-main. Okay, so I just want to show you that I have added, or here in MT1, so we should have a route, of course, and we should have a firewall NAT. So we could have a configuration without NAT, provided on our empty-main router, we will configure the necessary static routes. Okay, so that will be for another video tutorial. So for our computer that is on this 10.50.50.200, so we should be able to reach our gateway. Okay, so yes, we are able to reach our gateway. So let's try if we could reach our DNS server. So quad 1s has no issue. And finally, let's have some internet sites. And yes, so it's properly resolved and we are able to reach the internet site www.youtube.com. So since we now have a working site, which is the site 1, so all it's left is to replicate the configuration on our other sites. So site 2 and site 3 for that matter. So here we are now inside the MT2. So as a recap, MT2, so Ether1 is connected to the switch and should carry an IP of 10.00.2/24. MT2 has a connection to the LAN and it should carry 172.16.0.1/24. So that is why on the IP address, so 10.00.2/24 on Ether1, and you have 172.16.0.1 on Ether2. So next we could do a ping test, tools ping, and 10.00.254, and there is a reply to our DHCP server. So that is why on IP routes, so we have a default route to our empty-main router. We also have an IP firewall NAT configure in this particular router. So what's left is the IP DHCP relay configuration. So we have already this one. So site2 relay is the name. Again, the interface is the one going to the LAN, not the WAN, or going to the DHCP server. So going to the LAN. So the DHCP server is the IP of our empty-main. So the local address is the local IP address of this particular router, which is 172.16.0.1. We click enable and we apply the configuration. So what's left is to turn on our site2 test client, and we should see requests and responses, and hopefully the site2 client will also acquire the correct IP of this particular subnet, which is 172.16.0.0 network. So we now have turned on our test client. So let's do an IP DHCP here. And yes, Dora is successful, and yes, it acquires a correct IP on the subnet 172.16.0.200. So we could do a show IP to check the other IP address parameters. So we have the gateway, we have a DNS, and yes, we are indeed getting it from 10.0.0.254. So we could also do a test first to our gateway, which is 172.16.0.1. And yes, there is a reply. Let's ping our DNS server, and yes, there is a reply. And finally, let's do some DNS check. So ping www.mikrotik.com, and yes, it's properly resolved and there is a reply. So let's do a quick check on our MT3. So basically MT3 is Ether1 with 10.0.0.3. Ether2 will be 192.168.1.1. So IP addresses, so 10.0.0.3/24 on Ether1 and 192.168.1.1 on Ether2. And we now have also our default route going to our MT-main router. We also have our NAT masquerade rule and our Ipdgp relay. So site 3 relay interface, again going to our local area network Ether2. The DHCP server is 10.0.0.254, our MT-main, and the local address will be the LAN IP of this router. So we enable and we apply, and if you'll notice the status, we don't have any requests and responses, and we'll turn on our final test client on site 3. So we are here in our site 3 test client. So Ipdgp to acquire, and yes, hopefully it gets the 192 segment. Yes, 192.168.1.200. Let's take a look at more details of the IP. So we have the gateway 1.1, we have a quad 9 DNS, and the DHCP server is indeed coming from our MT-main. So for verification, let's try to see if we could reach our gateway. Let's try to reach our DNS server, and finally let's try to ping a different DNS, and yes, properly resolved, and we're able to reach our facebook.com site. So again, as a review, we don't have any DHCP server here in MT1 or our site router. So we don't have any DHCP server. There's no leases here. So if we go to MT2, so MT2, okay, so this is MT number 2. So Ipdgp server, we don't have any DHCP server configuration here. We don't have any leases. So it's MT2 and MT1, and we go to MT3. So Ipdgp server, there is no DHCP server here, and leases. So meaning to say, the IP addresses were really obtained from this DHCP server. So we have one for class A, we have one for class B or the site 2 network, and we have one for class C or our site 3 sample network here in our MT-main DHCP server or main router. As a summary, we have configured a DHCP server only on our main router. Site routers are configured with DHCP relay configuration instead, so that internal clients in these site routers are able to obtain IP address from the main router that is really the sole DHCP server in our demonstration topology. Thank you for viewing.